14, 16. Or do we allow Alice to present? Alpha, you seem to be having technical challenges, sir. Now that the two of them are seated together, maybe as one goes through the motions of finding out what's going on, we could allow Alice to present, if agreed, so that we do not waste a lot of time. Alice, are you ready to present, or you're using the same laptop? Alice?
They are using the same laptop. They are actually together, so...
You know, the 2 minutes you asked for chair of department are over, so I don't know. We bought time by engaging Dr. Ongunya Kiasi and...
Maybe we move to another candidate as they sort out the technical issue.
Okay, that's
the interest of time.
That's fair enough. Thank you, Dr. Aura. We go back to Aradi. Aradi, hopefully we've been able to sort out your issues now. You had already been introduced by Dr. Wekulo, who had been present that time, and I think I saw Dr. Genga also come in, and it looks like they are all now not there. But you can mount your presentation and proceed as I look for your supervisors. You have already been introduced, yeah.
Yeah, thank you, Dr. Sorry for the inconvenience of network. I was forced to move some kilometers away from where I was initially. But my study is effect of virtual physics programs on students' learning outcomes within public secondary schools in Kakamega sub-county. And what made me to come up with this study was readings from other researchers and publications on virtual learning in physics in secondary schools, and happening in other parts of the world, like Mexico, which has been using TV in lower secondary schools since 1968, according to Fabregas 2019. Also, USA is more advanced in virtual learning in all secondary schools using internet, according to researcher Pregosuka 2021. In Kenya, radio lessons have been in use even before the COVID-19, and this is the period when we saw virtual programs coming up. And they've been being used mostly in primary schools. And then during COVID-19, the Ministry of Education, Science and Technology rolled out virtual learning through radio and TV, through the government policies, through the channel, Edu channel. And in Kakamega County, we have more than 10 schools in every sub-county that have functional computer labs or computer rooms to run this platform of KICD virtual learning. And that is according to Aradi 2020. These programs are in place, these machines are in place, these guides are in place. Yet, the outcome on students, on learners in these schools has not been evaluated, especially in even my study area, Kakamega South. I reviewed different literatures from different scholars. There was a survey study that was dealing with online versus face-to-face by Helms, and he was dealing with students in Kennesaw University, USA, and he was able to find out that face-to-face students did better than the virtual learning students. There was also a comparative study on online versus face-to-face by Jefferson, 2019, and Paul. Also university environment, environmental science students. And from his findings, he was able to get that the online students improved in their performance. And then there was a comparative study also of face-to-face versus blended in secondary schools by Smith in New Zealand. And he got that there was no significant difference. And then also an attitude towards the learning outcome, and also to go to the attitude, we have strong attitude can be able to guide behavior according to ADOC 2009, and then motivation using virtual learning by Dyer 2005. Students can be intrinsically be motivated, have interest, confidence when they have virtual learning. So if you look at the other readers, we can see that they're dealing with the studies in the universities. There was a secondary school, but there was no significant difference. So with these mixed up results is what was making me to come out with this study. My study was guided with some definition of terms: academic achievement, which was the extent to which instructional objectives are attained in physics; attitude, the extent to which a learner likes physics as a subject; then motivation, extent to which a learner is interested in physics now and in future; then learning outcomes, students' academic achievement, attitude, motivation in physics. So outcome is covering achievement, attitude, and motivation in physics. And then these virtual learning programs are physics lessons for Form 2 students as aired on Edu TV platform and other platforms. The problem that is there is that most of the Ministry of Education, Science and Technology has invested very heavily in education to ensure access to education, which is very key to learners even in secondary schools. Physics virtual programs are increasingly being used in a third of schools in Kakamega South Sub-County. Kakamega South Sub-County has around 31 schools, but around 10 of them have fully installed computer gadgets. And then there was a slight improvement or an improvement in physics KCSE results in the year 2021, Part A, that is the students who did 2020, as compared to the KCSE 2018-2019. So I thought there is something that ignited that improvement, and that is virtual learning. That is why I went for that research. And then effect of physics virtual programs on students' outcome is unknown. The programs have been run on KICD and the Ministry of Education platform, but the results, the outcome is unknown. And then there is limited research on effect of physics virtual programs in secondary schools. As I have highlighted earlier, that most of the researches have been done in universities in other countries. The objectives of my study are to determine the effects of virtual physics programs on students' achievement in the subjects within public secondary schools in Kakamega South Sub-County. Objective number 2 is to establish the effect of virtual physics programs on students' attitude towards the subject in the public secondary schools in Kakamega South Sub-County. Then objective number 3 is to examine the effect of virtual physics programs on students' motivation in the subject within public secondary schools in Kakamega South Sub-County. These three objectives were the ones that led to development of the three research hypotheses. The study was guided by transaction distance theory by Michael Moore, 1990. And this is where we are saying that there is always a distance in any form of learning affecting the outcome. Through dialogue, amount of dialogue of virtual physics programs determine transaction distance. Then cost structure, how flexible is that cost structure for the physics learners and their needs. And then learners' autonomy, self-direction. Can learners have self-direction through the physics virtual programs? My independent variable was mode of learning, which I was able to break it into two. Use of virtual physics programs and face-to-face, and then dependent variable learning outcomes, which is broken into achievement in physics, attitude in physics, and motivation in physics. I was able to collect quantitative data and use cross-experimental research design using non-randomized pre-test and post-test. Pre-test in this particular case was used to establish the entry behavior or validity. And then post-test was to compare the groups to determine the effect of intervention. You get that from my independent variables. We have face-to-face and the virtual group. And the post-test here was to compare the effect of the intervention, the effect of the virtual. The treatment group comprised of schools that adopted virtual programs, while the control group purely face-to-face learning. My ethical consideration before going for the study, I got permission from approval from School of Graduate Studies, a research permit from NACOSTI, and then presented it to Sub-County Director of Education, Head of Institution, and even teachers, and even assured the participants of high level of confidentiality. The study location was public secondary schools in Kakamega South Sub-County, targeting a population of all Form 2s who are going to 4,000, according to the reports that I got from the Sub-County Education Office. Then the sample size, 351 students, gotten from the 4,000 students using Krejci and Morgan formula. Sampling, multi-stage sampling, so that that required sample is gotten for the study. Then simple random sampling used for specific schools to be used in the study. That is the groups of schools that I was using for mixed schools, 2 girls schools, and 2 boys schools, totaling to 8 groups of schools. Data collection instruments. The data utilize primary source of data collected from students in the experimental and the control groups using 3 research instruments. That is physics achievement test, student attitude questionnaire, and then student motivational questionnaire. The research findings on objective 1, effect of virtual physics programs on achievement, that was collected using physics achievement tests for both the case of pre-test and post-test. Then one way ANOVA was run for both pre-test and post-test. For pre-test, there was no significant effect on the performance of students. That is before the program was introduced, before the treatment was introduced. There was no significant effect on groups. P-value of 0.97 and alpha value of 0.05. Then for post-test, there was a significant difference, p-value of less than 0.01 at alpha value of 0.05. And the difference between the pre-test and post-test in the achievement test here is because of the treatment received. And that led to rejection of hypothesis 1. For objective 2, hypothesis testing on objective 2, effect of virtual programs on attitude. Data was collected using students' attitude questionnaire for both pre-test and post-test. One way ANOVA was run. Pre-test, no significant effect. That is on the attitude of the student. Post-test, there was significant difference. Alpha p-value of 0.01 at alpha standard value of 0.0. This significant difference in the scores between the pre-test and post-test for the attitude of the students towards physics as a subject was due to the treatment that was received. And this led also to the rejection of the second null hypothesis. Hypothesis testing for the third objective, effect of virtual physics programs on motivation. The data was collected using students' motivational questionnaire for pre-test and also for post-test. One way ANOVA was done. For pre-test, there was no significant difference within the groups. That is a p-value of 0.988 at alpha value of 0.05. And then post-test, there was significant difference. And this significant difference is due to the treatment that the control group, the virtual group received. This also led to rejection of the third null hypothesis. Interpretation and discussion of the findings. I was able to find out that blending virtual programs with face-to-face has a significant effect on students' achievements as compared to face-to-face only. The treatment group achieved higher scores. The score was the same in the pre-test score. P-value is less than 0.05 alpha value. And then the findings are similar to Smith, who did a study in New Zealand using experimental design with the same teacher on secondary students. The findings agree with Paul and Jefferson, 2019, for environmental science for students. And then in number 2, experimental group had significant higher attitude mean in the post-test than control. For pre-test, for the difference was insignificant. P-value obtained was less than 0.05. The findings are similar to U, 2013 in Australian University. And then lastly, experimental group had a significant positive motivation effect compared to face-to-face. Pre-test had no significant difference. The findings are similar to Smith 2013 for 2 classes using standard grades. We did experiment for 2 classes using a standard grade, but here I'm doing for 8 groups of different classes of students. I can conclude by saying that from empirical evidence gotten from my research, virtual physics programs have statistically significant effect on students' achievement as compared to face-to-face. Then virtual physics programs have statistically significant effect on students' attitude towards the subject than use of face-to-face. Then lastly, virtual physics programs have statistically significant effect on students' motivation in the subject than face-to-face. The study is very important because to be able to provide a deep understanding of virtual learning versus the outcome in the Kenyan environment. Virtual learning is where we are involving the digital part versus the traditional one, face-to-face. And then it will enable the formulation of a virtual learning policy, which is not there, and improve even the teaching practices. And it will be able to provide basis for further discourse on the effect of virtual learning on outcome in physics and even other subjects. I'd like to suggest that this study is vital, suggest to the county government of even Kakamega to liaise with other private public partnerships to roll out these programs in school. If it gets the necessary support, it can be very good. Suggest also to stakeholders in the education sector to embrace the study for policy and curriculum formulation. And also to suggest secondary teachers of physics consider incorporating virtual learning to improve learning outcome, which is one thing in the subject. And then suggestion for further study to bridge the gap the study has not handled, especially the aspects of virtual physics programs, apart from just like other aspects, apart from just the outcome. And then have similar studies done even in other sub-counties to measure if the same results will be found if we carry out the same study. I think I want to end there, and I thank you for listening. Thank you.
Thank you, Aradi. You used exactly 20 minutes. That was a good timing. On our program, it is Dr. Achie who was supposed to review the document, but is held up in our campus in Bungoma. I think they've had activities the whole of last week, I think, and today the Vice Chancellor must be there. So I took it up to review this, so I hope you have your pen and paper, and then Josephine will summarize these things into the report. One is apparently you sent to us a draft document because page 10 and page 44, there are sections that are highlighted in yellow. Whatever that highlight was supposed to mean, it only suggests to the reader that there was something that made you highlight that. So that's a bit of carelessness. That suggests that this document is still under review. Two, ensure that your abstract is capturing all the salient issues across the thesis, chapter 1 to chapter 5. Manual numbering has a problem. If you go to 4.6, you have numbered 4.6 hypothesis testing. Then you say 4.6.1, effect of virtual effects on students' achievement. That is actually the objective. And hypothesis testing comes after many things under that objective. The objective needs to be 4.6, for instance. And then the sub-components of that objective now come under. So you're tying in a table upside down. So get your numbering correctly. And then number 3, you need to present your chapter 4 coherently. I would say that maybe you begin with 4.1, which is introduction. You go to 4.2, which would be probably the sample or the respondents. You say something about those. And then 4.3, in my words, would be your objective one. And then your objective one, you would begin with your first chapter telling us what you are trying to do in that thing. What is your X, what is your Y there? And what is your way of analyzing that? And then you now go on to 4.3.1, perhaps, and talk about the invariates. These are the descriptive statistics. Those ones are usually, we need all that to understand what is going on. Your outcome variable, your X and Y, and then the control variables, if any. And then the second step, which would be probably 4.3.2, would be the bivariate. We need to see, now that you've given us the means and so on, are those means statistically different in tests at bivariate level? And if these are interval or ratio scaled variables, then correlation, Pearson correlation would do here, and other parametric bivariates. But that's where it stops. It just tells us that there is a correlation between this and that, or there is an association between these two variables if it is a chi-square. That's what bivariates do. The t-tests of this world. The t-test will just tell you that, yes, there is a difference between mean 1 and mean 2, and that that difference is statistically significant, and here are the results. It stops there. It doesn't make claims after that. That is why usually you need to go to multivariate statistics, therefore, as the third thing would be probably 4.3.3 then, multivariate modeling, where you now lay out your model and say, now that there is a relationship, we've seen a relationship and we didn't make any claims there, we would now want to pursue this further in a regression model and control for X2, X3, X4, X5 in a model, probably, and you bring in others. Maybe you have 2 models or 3 models of that regression. Then you can now, at the end of it, make a claim and say, controlling for X2, X3, X4, X5, X1 has a statistically significant effect on Y of this magnitude. That's where things are. So you lay out your results in that manner. After that, and if you use a regression model, then you need to give us the model diagnostics after the model, after the result, so that we see whether actually that model is fitting the data correctly. Usually there are almost 6 things that are there for linear regression, if you're using linear. After the model diagnostics, then you do the test of hypothesis. You now test the hypothesis. We've seen the results, we've seen every variable has been put in there, and the model diagnostics will tell you whether you left out some variables, model specification, whether it's correctly done, and things like that. So if we are satisfied that the model is good, then you can now test the hypothesis. Look at the effect of X on Y in the presence of all those controls. Then now you go to the discussion. So there are almost 6 things under each objective are properly in order and presented logically. And then you move on to the next objective. You haven't done that in chapter 4. And I'm afraid you need to do that for all those 3 objectives. But more fundamentally, Aradi, one-way analysis of variance, you're looking at a variable, your Y is measured on either interval or ratio. And there are groups, there are more than 2 groups on which you want to compare that measurement. So one-way analysis of variance is an extension of a t-test that only has 2 groups. So now, what that one-way analysis of variance will tell us is that, yes, there are 4 different means here, and that at least one of the means is different from the others, and that difference is statistically significant. Then once you detect that, we usually go further for post hoc. Now you look at post hoc tests and say which one is different from which one and what's the magnitude. But if it's not statistically significant, if the test is not statistically significant, the thing collapses there. You don't even go further to post hoc. Now, you have used one-way analysis of variance, which is fine to compare several means beyond 2. this is very good for an experimental study where things are very controlled. You have no external things. Things are very controlled, like probably in a lab setting, you've closed out things, you've closed out a lot of interferences. You can use this and claim that, yes, there is a difference between this and that this mean is higher than this, probably because of the intervention. But yours is quasi-experimental. I'm afraid you can't use you can't use one-way analysis of variance and then make a claim that because this mean now is higher than this, it is because of the intervention. When we know that physics can be affected by textbooks, probably every student having a textbook can affect their performance in physics. Having laboratories, schools that have laboratories probably do better. How about reagents and the things that you need in the labs? How about teachers and their teaching experience? And maybe they even examine this physics. Some of them could be even senior examiners. All that can come to bear on performance of physics. Now that people choose physics at secondary, it's not compulsory. How about if those who chose it are the top cream? Actually, in most schools, they don't allow you to choose physics if you are below the average of that class. So how about if we are seeing good performance in physics simply because it's the top guys in that school who took physics? So there are many variables that can affect performance in physics and not just your virtual programs. So to make a one-way analysis huge claim of this is what is causing this good performance, I think you are overstating things. There are ways of doing this. For instance, difference in difference, analysis that you could use. In summary, I think I would like you to reanalyze your data and go beyond those to see that you've taken away the effect of other things that we know can cause that. You're not in a laboratory setting. You're not closed things in there. These are people who are interacting with the world and other teachers. And suppose you are looking at school one and you're looking at their mock, and maybe they did a mock from another school, maybe Alliance High School. So what is the effect of these fellows sitting mocks from elsewhere and having other external influences on their own performance? You have not even told us how you have controlled for that. So quasi-experimental cannot just rest on one-way analysis of variance. And we will begin to talk if we can see a reanalysis of this data using the correct methods. Thank you very much. I would like to invite you to make a comment on this.
Thank you, Dr. The highlights in yellow, I think it was done after correction, so I was sending the document to also my supervisor. It was done after correction. So I think I'll be able to make that correction and send without one that is in yellow highlights. But that is the correction I made from the previous presentation. And then on numbering, I'll be able to look at it, especially on the hypothesis. And then also restructure my abstract to show very well from chapter 1 to chapter 5. Then also the third issue you raised is on chapter 4. Coherency, I'll be able to look at it. Also the guidance from my able supervisors to make sure that it is coherent. And then on modeling, the multivariate and the also regression, I was using their post-hoc, but I'll be able to look at it also with the guidance and also doing more research so that I'll be able to correct. And then I'll be able to look at also the objectives in model diagnostics, to see that it is running well, the advice that you have put across. And then
okay, we've lost Duncan again. I think ng'ombe mzima tumemla, tumebakisha mkia tu. Kwa hiyo we can do with that. I can see Dr. Ogenga is here, so we'll do a report which will be in the minutes. Thank you so much. Let me open it up to the boardroom, and we'll again go first with members of faculty and then students. Members of faculty, any input? Yes, Dr. Aura.
Thank you, Chair. Thank you, Aradi. Another nice study. Just like there was another one I said, I also want to have a talk with ourselves about the same. But the issue of ANOVA, I had advised, not really advised, but queried the student, the candidate, why he went for ANOVA and he had only 2 groups. Why not just a T-test? And I think you've gone a notch higher to talk about it. I didn't get his setup of the quasi-experimental very well. I don't know really how he did it, but when you look at the title, the objectives, the hypothesis, I would really want to know how he set up his experimental design, quasi-experimental design. But one big issue that I'm coming with, towards the end, I think at the implications, interpretation, the candidate was talking about virtual learning, and his study is on virtual physics programs. I want us to separate the two, because virtual learning in itself has a separation line with virtual programs, because he was not talking about digital technologies in the teaching of physics, like simulations, the ARs. He was talking about programs being mounted on infrastructure like TVs and radios, if I got him very well. And I think there is a real separation between the two things, and he shouldn't use them interchangeably. Otherwise, it will confuse the reader, and the findings as he presents them might end up not being very credible. So he needs to do that separation. Unless if it is in the whole document, which I haven't read, but I just thought I could bring it to his attention that he shouldn't mix the two. Thank you.
Thank you very much, Dr. Aura, for those comments. Hopefully that helps. Brenda, Hanani?
Yes, Dr. Oh, sorry. No, I hadn't realized this, sorry.
Oh, okay. Yeah, then put it down. Thank you. Any other? Before we close out this jam via Duncan? Okay, thank you. Duncan, you have your report.
Just 1 minute.
Yes.
Just 1 minute.
Yeah,
I went off a little bit. So I'm back. Just 1 second. So I was presenting my information. I don't know if you got the whole of it.
No, you left. I think you've had very serious connectivity issues today. Next time there is anything like this, you probably just need to come to Moost.
Yeah, I think that will be the best one.
So what is it?
Okay, I talked about that ANOVA because of the data that I collected. And then maybe other factors.
Chair.
Yes.
May I ask that we observe what you guided, that, the issues have been raised, so it is upon the candidate to work on those issues. He does not need to defend anything.
Okay, I'm sorry because I was off, but I'll stand guided and I'll follow the
issues. The reports will be available to you kindly.
Okay, thank you.
Okay, thank you. So allow us to move on to our next candidate, and that is Alfayo. Alfayo had already been robustly introduced.